In this video, I'm going to talk about how to use a bootloader and then use Octoprint to upload new firmware for your printer. I'm specifically going to talk about using an Enders 3 and a Creality 10. The default motherboards that came with them have different chips on them, and so I'm going to be showing those examples. Depending on your hardware, this guide should still show you the whole process of using a bootloader, setting it up, and then configuring Octoprint to enable your firmware. The firmware is already pre-built that I'm going to use, and there'd be multiple ways to get firmware for your printer, so we're not going to cover any of that today. So hopefully I'll have sections in the YouTube video so you can skip around and find the parts you need in the moment. I found all this information through multiple sources on the internet, and trying to put it together was a bit of a struggle, so I hope this helps you out in getting your printer so that you can more easily change the firmware. I'm going to talk a little bit about connecting your printer board up to your programmer before you can put a bootloader on it. In this case, I have a CR10 main printer board here. You can see the main chip, if you look really closely, is an AT Mega 26 or 2560, and so that's important to know what that chip is when we get onto later steps, so you can always try to look at that. You might need to use some magnification. This was just taking up a cell phone camera, but seeing that with your naked eye is actually kind of hard to do. The main thing that you're going to be looking for on these types of boards is the Icsp header, and that's these 3x2 pins right here. In my case, I have an MK2 programmer, and it has the same header on a little cable, so I can just connect that once you know which orientation, and so you might have to look up which pins. This header actually stands for the in-circuit serial programming header. Once we have the bootloader installed, we won't have to use this anymore, which is nice because it's a real pain to get to, but that's what you're going to be looking for. And on this board, it's right out here in the middle. If you were to have an Ender 3, for example, their motherboard puts it way over here, and it's too close to the edge to actually connect it, so I had to use these wires. And in this case, if I lined up the USB on my programmer to the front side the same way the USB here, I could just match them pin for pin. And right now there's no power to this board, and so this red line showing up on my programmer. With my programmer, you would see a green light once it's successfully connected the correct way and there's power to the board. And so this is connecting to your computer for data, and then oftentimes you'll need to just connect the mini USB to power so this board comes on and starts talking to this. And so that is how you can connect the hardware up to get your bootloader ready to be put on there. Now we're going to talk about the bootloader. The reason we want to install a bootloader is it makes it a lot easier to change out your firmware, because right now we have to have a programmer attached directly to the boards for the 3D printer, which is inconvenient, and you have to tear apart your printer to get access to. With a bootloader, the chips are actually able to utilize USB, and then Octoprint can be used to just upload the firmware. And so if you have an Octoprint setup, you can easily upgrade your firmware without changing anything or tearing into your printer. So that's why we ultimately want a bootloader. To load the bootloader, we're going to show you how to do this using the Arduino IDE. Now, the IDE is normally for writing code, but in this case we aren't actually going to use that functionality. We're just going to use the fact that it has a nice library of boards, and it already knows how to burn the bootloader. The settings you want to make sure and get set to start with are right here. There seems to be a little error with the menu. And this is the board manager, where you can come in here and select whichever processor you have. For a Creality 10 and 10S, the boards that come in them by default is a Mega 2560, and so they're already in the Arduino IDE. If you had something like an Ender 3, that board's not in here by default, and so I've added it in as an option right here. To get extra boards, if they're not supported by Arduino IDE, you want to come into Preferences, and then there's a URL. I'll post this specific link, which will work for an Ender 3 board, in the post of the video, but you might have to go find a specific one if you have a different board, depending on where it's supported at. Now, once you have the board actually selected, you come in here and pick a processor, and in this case, it's the 2560 and the other options that. Now, if you get it wrong, for example, I'm going to select this guy for the Ender 3, even though I'm doing the other one. You can come in here and say burn bootloader, and you'll see that it knows that there's a problem, and you don't have to worry about this. You then just have to go and figure out which board it really is. And so I'm going to go ahead and change this back to the correct board. And then the other thing is make sure you have your programmer set correctly. I'm using an MK2. A lot of people use Arduinos themselves because they're convenient if they have one, but just get that selected, make sure your port's selected for that programmer. Once all this is selected, you just click Burn Bootloader. It says it's going to take a minute. The bootloader in my case has a little orange light. I can see it's burning, and then it's done. It goes to green. So this is really the process to set up this bootloader that will be convenient. At this point, I'm going to flip over and show you how to set up Octopi to actually install the firmware with this bootloader enabled. We use the Arduino IDE to flash the bootloader, but there's actually a tool that happens behind the scenes, and you could do this all in the command line if you really wanted to. Let's say you had a lot of printers and they were all the same and you just wanted to burn bootloaders on them and you didn't want to go through the Arduino. These commands will show up. In my case, I'm in Linux, and so I did a PS and I grepped for AVR dude. That's the actual command that is used to put the bootloader on here behind the scenes. And so you can take this big command here, you can find these files, and you can whittle it down to something a little simpler, and you can even take the actual bootloader file and copy it out. So in this case, I'm used Snap and Ubuntu to install the Arduino IDE, and so this bootloader is actually down inside here, and this is the little bit of hex files that you need, and these are all the different chip settings. Now this was pretty convenient to me also, because when you configure the Octopi, I needed to understand some of how it does it also, and it uses AVR dude behind the scenes, and so you can check all these different options and see what's actually happening when you're changing GUIs if you need to dig around behind the scenes. Platform IO is a way that I actually built some firmware and I deployed Marlin on my Ender 3, and so I was also able to look at what it did behind the scenes and see that it's using, again, the AVR dude tool to make this all happen, and it actually gave me an option that I needed later on that we'll see in the Octopi. So this isn't really all that important. This is just what's actually going on behind the scenes. The files that are used for a Creality 10 bootloader is actually just looks like this hex all crammed in here, and that's what you're actually flashing. The Ender 3 has a very short bootloader. I'm not really sure how it's so much smaller, but that's as big as it is. And so if you wanted to run all of this from the command line, you can set it up and you could commit all this to a Git repo or something like that to make it so you didn't ever have to use the tools again. So not necessary, but just some insights into what's going on. Now that we have the bootloader installed on the printer board, we can use Octoprint to actually upload the firmware with that bootloader. And so I'm now going to show you the way you configure Octoprint to do this and show how it actually works. Right now I have connected the CR10 board to this instance of the Raspberry Pi, and if I clicked on connect here, it won't actually connect because there's no real firmware running on there, to just the bootloader. So the printer's hooked back up, but it won't actually do anything until we get the firmware. To do this, you go ahead and click on the settings, and you want to use the Firmware Updater. Now this is a plugin, and so you'll want to go and install this by searching in the plugins and install that first. It's pretty simple to do. Once you come into here, you want to upload your firmware however you get it. In this case, I built it using Platform.io and Marlin source code, but you could download it from your manufacturer if they have an updated firmware. However you need to do that, you can get it from this file. You could even use an URL. And you'll see here, typically on the Raspberry Pi, as long as this is the only board connected, it'll show up as USB 0. But before this works, we actually have to come change some settings in here. And this is pretty important. So we're going to be using AVR-Dude. This has to be installed on the Raspberry Pi, and so you'll have to SSH into your Raspberry Pi and do sudo apt-get install AVR-Dude. That's actually fairly straightforward. You can find other instructions on how to do that, but you'll want to select the AVR-Dude. You want to select the actual processor that you have. Again, this is the one that we have. You'll see the path has to be put in here. Once you click on test, it'll show up as valid. And then the programmer type. This is what got me confused initially, was it has to be wiring, and I found that out by seeing what Platform.io did to successfully install the firmware when it was running, and that's the option AVR-Dude uses. And so this is the one that is very important here, so make sure it's wiring. You can actually look at the options that the Pi is going to run, and so you can see it's going to be using AVR command line. So if you were to choose some other method, you can come in here and see those advanced settings. But for the most part, as long as you've got your correct option selected here, you type this in like that and you select wiring. These are the core settings you're going to need. And so once you've got that saved, you go ahead and grab a firmware. In my case, I just have firmware.hex sitting here. I open this guy up, and then I click flash from firmware. Now, this is going to take quite a while to successfully flash, so we'll probably cut some of that out in post. And now it's saying that it's verifying the memory, so it always writes the firmware and then reads it back out to make sure that it was correctly put on there. It took about 30 to 40 seconds to do the right part. And now we see that flash was done successful. After it read everything off, you can just go ahead and close out of this at this point. And if you click on the connect button, it actually connected to your printer, and you should be ready to start printing at this point. So that is how you upload firmware once you have a bootloader installed